As a beginner beekeeper, a more experienced beekeeper told me never to eat bananas before tending to my beehives because bananas smell like the bees' alarm pheromone. Naturally, I formed my own simple informal experiment to test what reaction my bees would have to the scent of banana. Seeing as scents play such a large role in bees' detection of pheromones, I attempted to mimic the scent of the pheromone to see what would happen. I placed a small chunk of banana into my beehives one day in early November, fully expecting to feel the fiery wrath of 1,000 bees. But, to my surprise, my bees had no reaction, other than the fact that some of them crawled onto the banana and started to lick it with their cute little tongues. My bees' lack of anger at me made me realize, first of all, that it is a myth that you cannot eat bananas before tending to your beehives. Second, it made me question if I had previously misunderstood the role of this banana-scented pheromone. This is 2-heptanone, which is composed of 7 carbon atoms, shown in black, 14 hydrogen atoms, shown in white, and 1 double-bonded oxygen atom, shown in red. And yes, it does smell like bananas. It is produced in the mandibular glands of honeybees as a pheromone, or a chemical signal that can trigger behavioral and physiological responses in other bees. Pheromones are vital to honeybees' ability to communicate with each other, including indication of potential threats to the hive. The most common hypothesis for many years has been that 2-heptanone serves as an alarm pheromone, but research in recent years has indicated that this may not be the case. This research was spurred by inconsistencies in other research. Although many agreed that 2-heptanone was an alarm pheromone, there was debate as to whether its function was to attract bees to the hive in order to defend it, or to repel other honeybees from potentially harmful situations. For example, if a bear were attacking the beehive, would the 2-heptanone pheromone released by the bees inside tell the other bees, "Help us fight," or "Stay away, there's danger here"? In order to determine the role of 2-heptanone in honeybee colonies, scientists placed various amounts of the chemical at the entrances of beehives. The presence of 2-heptanone did not cause any sort of defensive response in the honeybees. So what does 2-heptanone do? The researchers then tested the effect of 2-heptanone on 2 common beehive pests, wax moths and varroa mites. Because 2-heptanone is produced in the honeybee's mandibles, when one of the pests was bitten by a honeybee, 2-heptanone would enter the resulting puncture wounds. Wax moth larvae that had been bitten were temporarily paralyzed. The longevity of this paralysis was dependent on the dose of 2-heptanone they had received. On the other hand, varroa mites were also paralyzed, but it seemed that their paralysis lasted for a much longer period of time. Injecting the wax moth larvae and varroa mites with lidocaine had a very similar effect to 2-heptanone, indicating that these 2 compounds have very similar functions as local anesthetics. So could 2-heptanone actually serve as a defense against 2 of the honeybee's most common pests? We cannot be certain quite yet, as much more research is required in order to verify this newfound function. However, I am fairly certain that I can now eat as many bananas as I want before paying my bees a visit.